Hello everyone. Today we're going to discuss about the digital technique of modulation and demodulation. We already introduced with the analog type of modulation and demodulation. What is the mainly difference between the analog and digital technique of modulation? We can see here the digital technique includes two very special operation which is shifting or keying. What is shifting means? Shifting means the properties of the transmitted signal, which are phase, amplitude, and frequency, they are shifting between the two levels. They are 0 or 1. We already know that the digital signal includes two main signal. They are 1 or 0. So the basic properties of the transmitted signal, their phase, amplitude, or frequency is also shifted between these two state or levels. We can say that. So this is shifting of the signal. And what is mean by keying? Keying is a digital technique. We can compare it with a switch. Where K will be 0, the switch will be open, and where K will be 1, the switch will be closed. That's why it is the basic difference between the digital and analog signal. In the analog modulation demodulation, there will be no this type of operation of shifting or keying. Now, why should we do the modulation technique? This is a concern to us. What is mainly modulation indicates? Modulation technique indicates the mixing or modulating the message signal with a high frequency carrier. We can say that carrier is a high frequency signal. Why should we do that? After the modulation or mixing of the carrier signal with the message signal, we get a modulated signal. Why should we need the modulated signal? We need this type of modulated signal for basically two reasons. They are increasing energy to transmit the signal over long distance. How? We know that E is equals to hc by lambda, or otherwise it can be said that h nu, where nu is the frequency. If we increase the frequency, the E will be also increased. And the another reason is increasing the E causes the lambda to be shortened. So if we increase the energy by modulating, we will also reduce the antenna size that we need to transmit the modulated signal. The antenna size reducing will be economically optimal for our use in the production or use. So we should need the modulation technique. After sending the transmitted signal by modulating process, we also need to receive the message signal at the receiver side by extruding the carrier signal from the transmitted signal. So here in this block diagram, we can see that the data will be in baseband modulation, which means the mixing of carrier signal with the message signal. After that, it will be transmitted to the radio channel. Various type of radio channel we can have like optical fiber, waveguide, transmission line. At the receiver end, the data will be out by extracting the message only without the carrier signal. The carrier signal will be omitted here by the demodulation technique. We will also discuss about it. We only receive the message signal at the receiver end. We shouldn't need the carrier signal here. We only need the carrier signal to energize the message signal to transmit over long distance for our use. Now we are going to see the basic properties of the transmitted signal that we need to modulate it or modify it by the carrier signal. Let's see the carrier signal's instantaneous signal A sine omega t plus phi. Here is the amplitude, omega is the frequency, and phi is the phase. A is the amplitude. In the amplitude modulation, we will modify the carrier information, which is amplitude. In the frequency, we will modify the frequency. In the phase, we will modify the phase to transmit the signal. After that, we will go to the demodulation system. In the demodulation system, we only need two types of demodulation circuit. They are synchronous or asynchronous. These two types we have. In the synchronous transmission system or detection system, the modulated message will be received at the receiver end. The sender will send the message to the receiver. But in this detection circuit, we also need a carrier-like signal to extract the exact message signal. Why? We will compare this signal with the originally transmitted carrier signal to extract only the message signal. We will compare what? We will compare about the phase or frequency of the main transmitted carrier signal with this signal. After matching these two, we will extract the message signal only from the modulated transmitted signal. That's why this is called synchronization process. We will synchronize here the send carrier signal with the receiver end reference signal. Receiver end reference signal, which we will produce by the carrier oscillatory circuit or carrier generation circuit or by the synchronization circuit. Both way we can produce a reference signal which will be compared with the originally transmitted carrier signal in the phase or frequency case. This type of detection circuit is called synchronous detection. Here we can see that it is written here, it is possible to reproduce the transmitted signal by the synchronous process. We will need a replica carrier here of the same frequency and phase for the synchronous detection. Now we are going to talk about the asynchronous detection, where we will need know this type of reference information of the frequency and amplitude of the sent carrier signal. We will only need the modulated signal only in the asynchronous detection. So further, we can say that in the asynchronous detection, it can be said that envelope detection. How? In the asynchronous detection, the sent carrier signal will not be needed here as our reference. We only need the modulated signal to extract the main message. We will need no some kind of reference signal which will be same for the phase or frequency as the sent carrier, as we need in the synchronous detection. We will not need here. So the basic idea, we can say that the synchronous detection can be called product detection, which will multiply the reference signal with the originally transmitted carrier signal to extract the message signal. In this technique or in the asynchronous or technique, we can say that it is envelope detection by using this envelope detection circuit, where we will have the modulated signal or only a diode and a resistor. We will get the envelope detection circuit. By this circuit, we will get the originally message signal without needed the carrier signal as the reference. We will not need it here. So if we want to summarize the overall concept, it is the message signal. We can assume it is the carrier signal which is high in frequency. As you can see here, the time period is here very low, so the frequency is high here and the frequency is low here in the message signal. This two signal will be modulated at the transmitted side, or the transmitted modulated signal will be sent to the receiver, and at the receiver side the receiver will be go through the asynchronous detection or synchronous detection to extract the message. If we use the asynchronous, we will use this envelope to extract the main message as the same here. If we use the synchronous, we will need also a carrier at the receiver side to multiply it to extract the message from this signal as same as this. Hope you have understand the basic system of digital modulation and demodulation technique. Further, we will go through the different techniques analyzed with the deep basic of these three types of modulation technique, which are amplitude, phase, or frequency, and their demodulation circuit. That's all. Thank you all.